Hello and welcome to 5.1, writing linear equations in slope-intercept form. So far we have seen slope-intercept form, standard form, how to graph it, and all that stuff. If you haven't figured it out already, we keep repeating and reviewing linear functions. So what we're going to do today is we're just going to kind of take slope-intercept form and expand on it. Okay, it's not just just graphing. We're going to kind of talk about how we build it and all that stuff. So recall that slope-intercept form, again, is y equals mx plus b, where m is our slope and b is our y-intercept. As a reminder, our y-intercept is always going to be 0, comma y. So what we're going to do first is we are going to write an equation given our slope and our y-intercept. So we're just going to plug in these values. So we have our slope is -2 and our y-intercept is 4. So our equation is going to be y equals -2x plus 4. As a reminder, don't forget that x and don't forget the y equals. We need them because that creates that slope-intercept form. Okay, our next one, we are given that our slope is 1/2 and our y-intercept is -1. So our equation would be y equals 1/2 x minus 1. And so comparing these, since number 1 has a negative slope, the line would be going down, but it would be steeper than example 2 because of the 1/2, but our line for example 2 would be going up because it's a positive slope. So what we're going to do next is we're going to write an equation given a graph. Again, we've already done this, but again, it's good to kind of keep reviewing it. So our y-intercept, that's where we cross our y-axis, is 3. Remember, we can write it as a actual point, which would be 0, comma 3. Another point, again, we want a lattice point. So the point, it's already kind of marked, is 2, comma 1. And so we're going to count. So it's rise. So in this case, we went down. So -2 over 1, 2. And so our slope, remember, is that change in y over the change of x, also known as rise over run. So in this case, we would have -2 over 2, which simplifies to -1. So bringing our y-intercept and our slope together, we would get y equals 3x minus 1. Okay, now let's do example 4. So our y-intercept is 2. Our other point is our x-intercept, so that's going to be x, comma 0, so in this case, -3, comma 0. I'm going to count. I go down 2, back 1, 2, 3. And so my slope, rise over run, simplifies to 2/3, which makes sense because our line is going up, so we should have a positive slope. So our equation is going to be y equals 2/3 x plus 2. And so there is our equation for this line. Okay, so writing equations of constant functions. So these are our horizontal and our vertical lines. So horizontal lines cross the y-axis. So remember, that's our HOY. I've talked about it a lot. We're just going to write it down now on our notes. So HOY stands for horizontal. The O is really a 0 slope, and y equals. That's because when we graph it, it's a horizontal line. There's no going up. Now our vertical lines cross our vertical axis, and so it's a VUX. So it's, again, stands for vertical, undefined slope, and x equals. And that's because when we have our graph, it's a perfectly vertical line. We can't survive on that. That's why it's undefined. So what we're going to do is we're going to write an equation that's a horizontal line. So that's a HOY, so HOY. So that means we're going to have y equals. That passes through the point through -3, comma 7. So what this means is we want to look at the y value. And so our equation is going to be y equals 7. because if we were to graph it, here's where y equals 7, that point -3, 7 would show up right there. So number 6, we are asked to find a vertical line that passes through -3, 7. So the same point, we're just now going to look at x equals, because this is a vux. And so we're going to look at the x value. So our equation would be x equals -3. And again, if we wanted to look at this, we would have a vertical line at x equals -3. And our point, -3, 7, would show up right there. So now what we're going to do is we're going to kind of bring those together. We're writing equations of our vertical and horizontal lines that pass through the point 5 and 1. 5, -1. So our horizontal is a hoi, so horizontal zero slope y equals, so that'd be y equals -1. And our vertical is a vux, vertical, undefined x equals 5. And so again, if we wanted to visualize that, we would have y equals -1 and x equals 5. And that would be the point right there, 5, -1. Okay, now let's look at a word problem. So you borrow $50 from your brother. To repay the loan, you pay him $10 per week. Write a linear equation to model this situation. So we borrow $50 and we want to repay the loan, and so we're going to pay him $10 a week. So we're going to have y equals mx plus b. Well, we start with $50. That is our initial. That's how much we have to pay back. Now, because we're paying it back per week, we are actually going to be our slope is going to be -10x. And that's because x represents the number of weeks. This is our defining of our variables. And then our y value, this is the total money left to pay. Okay. So let's look at example 9. So John Deere rents out riding lawnmowers for a flat fee of $45. I'm going to pause right there. A flat fee is no matter what you do, like if you don't do anything with it, you still have to pay $45, just in a sense to look at it. So this would be our initial. And an additional $10 per day. So what we're going to write is an equation representing our total cost. So y equals, in this case, we would be adding $10 to our total of $45 for our initial fee. And again, we want to label our variables. So x would represent number of weeks. Oopsies, not weeks. Ooh, didn't read my problem again. Days. And then y is our total cost. Where I got that is right here for the total cost. Okay, let's go to our next page. So writing linear equations given the slope and a point. So this was a little different. So we're not given our y-intercept. We have to kind of figure it out. So we're still going to use that y equals mx plus b, but what we're going to do is we're going to plug in our point x and y into our function and then solve for b. And then write our linear equation. So again, this is what we're going to do. Y equals mx plus b. We have our slope, which is 3, and we have our coordinate x comma y. So we're going to plug those in. So y is 4. My slope is 3. My x value is -1. And then we have plus b, because we don't know what our y-intercept is. So now what we're going to do is we're going to simplify our work. So we get 4 equals -3 plus b. I'm going to add 3 to both sides to get 7 equals b. So now that I have my slope and my y-intercept, we would get y equals 3x plus 7 as our equation. Okay, let's look at example 2. So we have, again, y equals mx plus b. We have x and y, and we have our slope. So I'm going to plug everything in. So y is 5, our slope is -1, our x value is 2, plus b. -1 times 2 is -2. And then I'm going to finish by adding 2 to both sides to get 7 equals b. So now that I have my y-intercept, and again I have my slope, we would get y equals -1x plus 7. Again, if we want, what we should do really is we don't really need that 1 out in front. And so there we go. Okay. Last one, we have our, this one's a little different because it says we have our x-intercept of 5 and our slope of -3. Well, even though it's not saying a point, it is a point because remember, an x-intercept is always our intercept, comma 0. So since we have that, we can plug it into our, again, y equals mx plus b. So our y value is 0, our slope is -3, our x value is 5, and we're solving for our b value. So we get 0 equals -15 plus b. I'm then going to add 15 because I'm isolating b. Again, what we do to one side, we do to the other. And so we get our y-intercept, we have our slope, and so we would get y equals -3x plus 15. There we go. Okay, we got one last problem, parallel lines. So parallel lines have the same slope. So if we're asked to find any line that's parallel to y equals -1/2 x plus 3 and passes through a different point, what we have to do is recognize that for it to be parallel, we have to have the same slope. Oopsies. So we now have our slope and a point, x, y. So I'm going to do the same thing I did on the other side. Oopsies. Y equals mx plus b. I'm going to plug everything. So 1 for y. My slope is -1/2. My x value is -2 plus b. Well, what's nice about this is we would get 1 equals, well, -1/2 times -2 is +1 plus b. And so we are going to then subtract 1 from both sides, and so we get 0 equals b. So we have our y-intercept and our, oopsies, not that. We have our slope. And so y equals -1/2 x plus 0. Well, we don't really need that 0, so our answer would be y equals -1/2 x. So what we're going to do for our last piece is just kind of verify it by graphing both of our lines. So I'm going to graph my original problem because that is my constant. We are given that. So my y-intercept is +3. My slope is down 1, right 2. Down 1, right 2. Down 1, right 2. Oh, and you guys get to see my ruler. Okay, so we have our ruler. Again, we're going to line it up. And then we're going to connect our points. Make sure we're going through the entire graph. And I'm going to write it down here. Y equals -1/2 x plus 3. So there's my first line. Now I'm going to check to see if what I just found is parallel. So my y-intercept is 0. I'm going to go down 1, right 2, down 1, right 2, down 1, right 2. Okay, so far we're looking pretty good because it has the same slope. And our lines are parallel. They won't intersect. So y equals -1/2 x. I'm just going to double check. Did it go through the point? -2, 1. -2, 1. Well and behold, it did. So we're good. Okay, and so that is the end of 5.1. Linear functions in slope-intercept form. Okay, come to class with your questions.